Hello, everyone, and welcome to today's virtual connection highlighting undergraduate research at the University of San Diego. We are happy you are here. My name is Kara Marsh-Profit, and I am the Director of Alumni Operations and Engagement at USD. When we were sent home to work remotely in March of 2020, the Alumni Association staff pivoted to virtual engagement. And while Zoom is no true substitute for being together in person, it has enabled USD to connect with Toreros far and wide. Since then, we have hosted nearly 300 virtual events for our alumni and friends. I am thrilled to be partnering with the Office of Undergraduate Research in hosting this connection for you today. The mission of the Alumni Association is to engage and enrich the Torero community for life. Today's connection is rooted in the desire to offer meaningful ways for our community to stay in touch and to remain connected to the good work happening at the University of San Diego. Without further ado, I would like to introduce my colleague, Elisa Green, who will be facilitating today's virtual program. Elisa received a Bachelor's of Science in Marine Biology from UCLA and a PhD in Marine Biology from Scripps Institution before moving on to Harvard as a National Science Foundation Minority Postdoc Fellow. After her stint in Cambridge, Elisa ran the STARS Summer Research Program at UC San Diego before moving a few miles south in 2017 to join us at USD as a director for the Office of Undergraduate Research. Elisa, there you are. Welcome. Thank you so much for being here, and I invite you to take it away.
Thank you, Kara, for the introduction, and thank you everyone for being here. Before we go to the presentations, I just wanted to give a very brief introduction to undergraduate research at USD. It's a really important component of a USD student's education. It helps them translate what they're learning in the classroom to real life and helps them prepare for their future careers. USD students have many opportunities to conduct research. Most of them take a research or a senior capstone course as part of their major, but many of them also volunteer doing research, and there are also several ways that students can get paid to do research at USD. Some of the programs that we have at USD include the pre-undergraduate research experience, which is for entering freshmen and transfer students, where they do research for 8 weeks during the summer with the professor. We also have the summer undergraduate research experience, which is open to all majors, and students in after their freshman year and beyond can do research for 10 weeks during the summer and get paid. And then we also have the Keck Undergraduate Humanities Research Fellowship, which is a program for students to conduct research during the academic year. We also have some programs for students for off-campus to help encourage them to come to USD. We have the National Science Foundation Research Experience for undergraduates program, which we had a few years ago and had a little hiatus, but I'm happy to say that we've renewed it and it will start again this year. So with that, I would like to introduce our first speaker, who is Parker Clay, and they are doing their research as part of the senior capstone, as part of their senior capstone. And also, Parker was a participant in the NSFRU program a few years ago and transferred here to USD as a result. So welcome, Parker.
Hello, everybody. I'm Parker, and my research was on the effect of sea surface temperature and Chlorophyll-a on the abundance of tunas along the coast of Southern California over a 60-year time period. So just a little bit of an introduction. According to the IPCC report in 2019, average global temperatures have risen by about 1 degree Celsius, and sea surface temperatures are on pace to match that. And why is that a problem? Well, half of Earth's total ecosystem goods and services originate from marine ecosystems that are highly impacted due to anthropogenic pressures such as increased atmospheric temperatures and overfishing, including tuna fisheries. And tuna is among the most valuable fishes on the planet. The Pew Charitable Trust estimates that nearly $41 billion are contributed to the global economy every year, with $27 billion from the Pacific Ocean alone. However, tuna fisheries are overfished and stocks are in a state of decline, having peaked anywhere from 15 to 50 years ago. And tunas are highly migratory species that are sensitive to global and regional climate changes. And the waters off our coast are known as a zone of upwelling that is characterized by high productivity. And previous studies have shown that the California current is one of only 2 major currents around the globe that has experienced cooling rather than warming. And these studies have shown that cooler waters and higher concentrations of chlorophyll-a associated with high productivity may adversely affect the abundance of tunas along the coast of Southern California. So the purpose of my study was to investigate how sea surface temperature, chlorophyll-a, and tuna abundance has varied from 1959 to 2019, and to examine the relationship between sea surface temperature and chlorophyll-a on the abundance of both larval and adult tunas. So to get started, I obtained larval tuna data and hydrographic CTD data from Cal Coffee, and per se tuna fishery data was obtained from the Inter-American Tropical Tuna Commission, or the IATTC, which governs tuna catch in the Pacific Ocean. Mean sea surface temperature and chlorophyll-a concentrations were calculated by averaging and combining all Cal Coffee stations that fell within the study location, marked by these white and blue icons. Per se tuna catch was then combined for all species at all locations within the same area, and catch per unit effort was standardized as metric tons per set. So here's the first result. And as you can see, the mean sea surface temperature and chlorophyll-a concentrations were pretty variable over the years. However, the 3 warmest years observed were in 1983, 1988, and 2015, which averaged above 18 degrees Celsius. Also, there was a significant negative correlation between sea surface temperature and chlorophyll-a, p-value less than 0.002. Here are the results from the tuna abundance. Again, results were pretty variable. Total tuna catch peaked in 1978 and 1986. However, there were a few years where no tuna were taken at all. I also looked at seasonality. In summer, which is represented by this orange line here, was by far the most productive season. Approximately 82% of the total tuna caught were taken between the months of June and September. And of the 5 species I looked at in this study, the Pacific bluefin, or Tunas orientalis, made up most of the catch at 62%, which is the blue line you see there. It's important to note that larval tuna was not detected at all throughout my study location during the 60 years. When analyzing the relationships between sea surface temperature, chlorophyll-a, and tuna abundance, I found that there was a significant positive relationship between annual sea surface temperature and tuna catch. The value was less than 0.005. Less than 0.05, and there was a significant negative relationship between chlorophyll-a and tuna catch with a p-value less than 0.01. However, both R-squared values were relatively low. So while there was a significant significant relationships between sea surface temperature, chlorophyll-a concentrations, and the total amount of tuna caught in a particular year, there is a fair amount of variability. A weak R-squared value suggests that other factors may contribute to where these tuna are most abundant. Most species of tuna prefer warmer waters where naturally chlorophyll-a concentrations are lower. Results from generalized additive models and previous studies showed that warmer temperatures, particularly around 17 to 21 degrees Celsius with lower surface chlorophyll concentrations greatly increase the probability of occurrence of both Pacific bluefin tuna and yellowfin tuna. Also, variations in the population abundance of these tuna are strongly linked to large-scale climate indices, such as ENSO, or El Nino Southern Oscillation. And when comparing the results of the tuna catch in this study to the ENSO index, peaks in tuna caught correspond to increased water temperatures brought on by strong El Nino events, such as those in 1982, 1988, and 2014. And the patterns that I observed are pretty consistent with those documented by several other studies. The fact that no larval bluefin tuna or any other tuna were detected suggests that there was a spatial and temporal disconnect. Most Pacific bluefin tuna remain in the Western Pacific after being spawned off the coast of Japan, but a proportion make extensive migrations to the East Pacific late in the first or second year. And these trans-Pacific migrations from west to east are strongly linked to local sardine abundances off the coast of Japan. When these sardine populations drop, a greater percentage of bluefin tuna are proposed to move to the East Pacific. Strong El Nino years are associated with higher stocks of sardines in the East Pacific. Using this Cal Coffee and IATTC data, I was able to determine that tunas are more abundant when sea surface temperatures are warmer, typically greater than 17 degrees Celsius, and surface concentrations of chlorophyll-a are low. However, looking at these two parameters alone to predict tuna abundance isn't enough, and other factors such as these large-scale climate indices should be considered in future studies. And with that, thank you everybody for listening, and I'll open it up to Dr. Green for questions.
Thank you. I did have a couple of questions. You did a really great job on your presentation. For your study, did you actually analyze samples, physical samples, or was it all just data from your computer?
No, it was all historical data that was collected off from cruises that Cal Coffee does. They collaborate with Scripps and NOAA Fisheries to maintain like the health of the coast of Southern California. They monitor water conditions, larvae from different species to monitor fisheries and other stuff like that. So I just collected all of the data from that and then put that together.
Great. And when did you start this project?
I started this project last September during COVID.
During COVID. Yeah, so this is a really great example of how you can still conduct a really cool research study remotely, even though when you don't have access to the lab.
Right. It was challenging for sure.
Yeah. What was the most challenging part about it?
I had huge data sets. So combing through 3 different data sets with more than 1 million data values in each was challenging for me when I didn't have experience with handling data sets that large. And I didn't have access to typical resources that I would on campus. So figuring that out on my own was challenging. Did you have help from your professors with that? So, of course, yeah.
But all remote, I guess.
All remote, yeah. Yeah. I could pop by office hours, had to schedule and stuff like that.
We do have a question from the audience. What is the effect of global warming and climate change on the tuna population?
I don't know that question. It's kind of complicated because there are different aspects of climate change you have to look at. So my study particularly looked at like warming or cooling sea surface temperatures. So there have been studies that have shown that in areas where there are warmer waters, there are typically greater abundance of tuna. So you would think that there would be more, but there are other factors such as overfishing that are at play. Most tuna fisheries, the stocks peaked 15 years or between 15 and 50 years ago. And I know Pacific bluefin was about 30 years ago. And ever since then, they've just been declining. So looking at it is a little bit more complicated. That question is pretty complicated.
Yeah, I think you did a really great job explaining it though. Yeah, and I think that's it. We'll move on to the next speaker. Thank you again, Parker. Great job today.
Thank you, Dr. Green.
So our next speaker today is Gabriella Whittaker. And Gabriella was doing her research as part of her senior capstone. So Gabriella.
Hi, yeah, thank you, Dr. Green. I'll go ahead and share my presentation. Just a second, sorry. Okay, so hi, yeah, I'm Gabriella, and I did my research on the effects of the Pacific North American pattern on snow water equivalent in the Northern Rocky Mountains. So I chose to research this because I grew up in Idaho and I've been skiing in the Northern Rockies my whole life. And throughout my life, I feel like I've noticed a decline in the heavy snow years that shaped my childhood. And so I wanted to dig into why this is happening and if it's actually happening. So just this spring, I was home in Idaho while finalizing my research project, and we're facing yet another drought year. So this topic and project has been very personal to me, and I've really enjoyed looking into it. So as we all know, our climate is changing faster than what we'd like. And with these changing global temperatures come many domino effects. One of those is the decline in terrestrial snowfall and snowpack. So in the Western US, over 80% of our fresh surface water that we depend on comes from mountain snowpack. And as that freezing level gets higher and temperatures are warmer, our water supply and storage will be depleted. Another effect of decreasing terrestrial snowpack is a lower albedo. Snow has a very high albedo, which reflects incoming solar energy back into the atmosphere. However, when there's less snow, more sunlight is absorbed into the earth, and this causes a positive feedback loop of warming. So this first image is the mountains in Idaho last year, which was yet another drought year, and the snowpack is far below average. To begin, I'd like to identify the key terms I'll be using in my presentation. So the measurement I'm using to measure snowpack is snow water equivalent. And you might see that as SWE in my slides and graphs because it's a lot to type out. But that's the amount of liquid water present in the snowpack if you were to melt it down. And I chose this measurement because it directly relates to the amount of water that's being contributed to the adjacent watersheds. And next, I'll explain the Pacific North American pattern. The PNA is determined by the Asian Pacific jet stream, and its positive and negative phases correlate with geopotential height anomalies. So in other words, it affects where those areas of low and high pressure exist over the United States. You can see on the left-hand side, this is the positive phase. And in the Western United States, that results in a high pressure zone, which typically causes warmer temperatures and less snowfall. Previous studies have shown that in the past 50 years, the PNA has tended to be in that positive phase during the winter, which results in milder winters for the Western US. So using these two variables, my study asks two questions. How has snow water equivalent changed over time? 37 years is the period I looked at 4 stations in the Rocky Mountains, and how is snow water equivalent associated with the Pacific North American pattern? My methods involved identifying 4 high elevation snowtail stations in the Northern Rockies. I chose 1 station in Idaho, 1 in Wyoming, and 2 in Montana. And I chose these just because they had the oldest snow water equivalent data and that dates back to 1983. All of my data was collected from online sources. The snow water equivalent is from the NWCC's historic SNOWTEL data, and I used the SWE from April 1st. So I chose this date based on previous studies that examined the accumulated winter snowpack. And my PNA data was retrieved from the World Meteorological Organization. I averaged the monthly PNA index from January, February, and March, as these would involve the snowfall accumulation leading up to the April 1st snow water equivalent measurement. Finally, I linearly regressed the snow water equivalent with the PNA phase in order to examine this relationship. This first graph is in relation to my first question, which is how has snow water equivalent changed over time at these 4 stations in the Rocky Mountains? So you can see some large fluctuations between the yearly snowpacks, but my p-values at the bottom showed no significant upward or downward trend at these 4 stations over the 37 years. So that means that snow water equivalent has stayed fairly consistent on April 1st at these stations. This next graph shows the relationship between the late winter PNA phase and the April 1st snow water equivalent. After linearly regressing this data, I was able to find a p-value of 0.00376. And this is statistically significant, so that means there's a relationship between the 2 variables. And as you can see from my regression line, that relationship is negative, which means that a higher PNA index results in a lower snow water equivalent. My R-squared value, however, was quite low, and I'll get into that in a second. So I was pretty surprised by my first result because I found no significant decrease in snow water equivalent over the past 37 years. Based on previous studies, I had expected the snowpack to be decreasing due to continued warming of our climate. So this seems like good news for now, at least. However, I have to point out that I only use data from 4 stations out of the many that exist in the Rockies. And my stations were all at around or above 9,000 feet, which is typically still above freezing level during the months that I studied. So that means that even if there are warmer temperatures, it's still snowing and it's not warmer than the freezing point. So I think that future studies need to look at studying stations at lower elevations or study these same stations but later into the spring when temperatures are warmer at high altitudes. My second result matched what previous studies had found and my own hypothesis, and that is that the phase of the PNA would be negatively correlated with snow water equivalent. This makes sense because the positive phase of the PNA results in high pressure over the Western US, which means warmer temperatures and less snowfall. That being said, my R-squared value was 0.05923, which is pretty low, but that just reinforces the fact that snowpack is affected by a multitude of factors. And this graphic shows some like aspect, slope, wind, vegetation, and many others. So the PNA is just one of many influences on the snow water equivalent, but it does still influence it. Oh, I have one other result that I just wanted to mention is that within the past 15 years, 10 of those winters have seen the PNA in its positive phase. So a previous study that I looked at determined that to be true up until 2005, and then I examined the winters from 2005 until 2020, and I confirmed that this pattern has persisted, and that means that winter conditions are milder more often than not. So in conclusion, my study supported the fact that the PNA does influence alpine snowpack at least to some degree, and that this pattern should continue to be closely monitored. Next, my results show that April snow water equivalent has not been declining in the past 37 years at the 4 stations that I examined. However, my study is too limited to speak for the entire Rocky Mountain range, and furthermore, the high elevation of these stations may limit any significant warming from happening until later on in the year. Finally, my biggest conclusion is that this topic needs to be studied much more extensively, using far more spatial data and also examining snow water equivalent later into the spring months to understand alpine warming and snowmelt. So here's my whole poster one more time. Thank you. And Dr. Green, do you have any questions?
Yes, great job with your presentation too. Again, for the audience, if you have any questions, you can type them into the Q&A or in the chat box. But I did have a question about how you conducted this study again, if you could expand a little bit more on that, how you conducted it, especially in the time of COVID. Did you have to learn any new programs or anything that you were able to do from home?
Yeah, so I started looking into this during the fall semester in a climatology class that I took with Dr. Yin at USD. And then for my senior capstone, I expanded it and made it a little bit more specific, and also looked at these patterns like further back into time. And so I did have to learn a lot because I collected all of my data from online sources. And so kind of like what Parker was saying, I just had these huge data sets in Excel, and it was a lot to figure out of like how to organize it and how to get what I want. And it worked, but it's definitely different not being in person with your professors and having them over your shoulder, just being like, oh, just do this. It's so much easier than the hours of time that you're putting into it. But yeah, I learned a lot.
Cool. What are your plans for after you graduate or the summer? Is anything related to what you studied?
Not specifically related to this. I'm actually an environmental studies major, and so I'm going more into the business and policy side of things rather than field research. But I did really enjoy this project.
Cool. It looks like we don't have any questions from the audience. So thank you again for a great presentation. Yes, Parker and Gabby both represented Environmental and Ocean Science Department. Oh, we do have a question. Are April SWE measurements affected by earlier season snow, or is it an accumulation of snow from the entire winter?
Yeah, so it's the accumulation of the entire winter. And I chose like the April snow water equivalent because that's what past studies had done when looking at the accumulated snowfall. And then afterwards, I realized that my stations are at such high elevation that if it were, like if temperatures were warm enough to have that snow be rain, it would be lower down, which is the studies that I looked at were examining lower elevations. So yeah, it was the accumulation of the whole winter, but probably not much melting had occurred before April 1st.
Okay. Well, thank you. Great job again. And our final speaker is Samuel Hixson, who also conducted his research as part of a senior capstone, but was also a Keck Undergraduate Research Humanities Fellow, which is one of our programs where you get paid, students get paid to do research during the academic year. So Samuel, you can begin.
Awesome, thanks for having me. So my name is Samuel Hixson. I study interdisciplinary humanities and biochemistry. And first I'll tell you a little story about how I was inspired to do this project. So I'm from Hawaii, and last summer I was working as a lifeguard at a pool, and it was about 10 a.m. in the morning, and I got a phone call from a sailor I know, and he said, "We're doing a sailboat delivery from Hawaii to California. Are you interested?" And I said, "Yeah, I'm sure I'm interested. When is it going to be?" And he said, "We're leaving tonight." And so I rushed home and I packed a bag and I hopped on this sailboat and we sailed to California. And over that time, the 17 days, I was imbibed by the vastness of the ocean and really with a sense of awe and wonder for nature. And also saw a lot of pollution and plastic trash floating. And so that inspired this project, From Sustenance to Decadence, a literary and scientific discussion of modern lifestyles driving climate change. And so today, our lives are more intertwined with technology and material wealth than ever before in history. In the audience, just think, can you raise your hand if you own both a smartphone and a computer? So almost everyone, see some hands going up, almost everyone owns both a smartphone and a computer. At the click of a button, you can buy anything on Amazon, from a toothbrush to a surfboard, and have it delivered right to your doorstep. So a 2019 Nielsen report shows the average American spends over 11 hours each day on media, whether that's listening to the radio, watching television, on your smartphone, on social media, or on the internet at work. And these increasingly technological lifestyles are accompanied by an alienation from nature. They provide more avenues for advertisers and messages from society to inundate our lives. And they're also driving what may be the greatest existential threat to humanity, which is what we're discussing today: anthropogenic or human-caused climate change. And so today, we will discuss Henry David Thoreau's notions of necessity and the common mode of living, and we'll apply those to our 21st century lifestyles. Then we will look at how news media ownership helps to forge consumerism in the United States. Third, we'll introduce anthropogenic climate change and the science of it. And finally, we'll take a look at how literature shows reconnecting with nature can alter one's worldview to care for the environment. And so to begin, we'll discuss Henry David Thoreau's notion of the common mode of living. And as many of you probably know, Thoreau went to the woods in Massachusetts in 1845, where he built a small cabin and lived for 2 years in it near Walden Pond. And his idea of the common mode of living is that the conventions of society are uncritically accepted as correct and adhered to. So he writes, "It appears as if men had deliberately chosen the common mode of living because they preferred it to any other, but they honestly think there is no choice left." Now, his issue with the common mode is that it strays from necessity. And so necessary things to him are those which serve to keep us alive, such as food, shelter, clothing, and hence he criticizes the superfluous luxury of large houses, extra clothing, and technology like the telegraph and the railroad in his time. He calls these positive hindrances to the elevation of mankind because they come at a large life cost to obtain. And so here's a quote he gives: "A monkey at Paris puts on a traveler's cap, and all the monkeys in America do the same." And so the idea is that the common mode of living, and fashion in this case, is uncritically accepted. So a modern version of this quote would be: an Instagram influencer puts on a H&M shirt, and everyone rushes to buy H&M and wear it. And today, here's a scientific phenomena called spontaneous synchronization, which is analogous to the common mode of living. So here we see discordant metronomes. They're all ticking at different times. And after a few minutes, they all tick in unison. So this is analogous to the common mode, where people get worn into the conventions and the treads of society and those behaviors. And today our common mode of living is flying in airplanes, driving cars, interacting with our smartphones and technology thousands of times each day. And the life cost of this is the average American spends 90,000 hours, mostly of central adult years, at work to afford these aspects of our lives. And Thoreau writes, "Our lives are frittered away by detail. We have little time to be unhurried and wise, perceiving that only great and worthy things have any permanent and absolute existence." So this is largely characteristic of our lives today, where Pope Francis describes us as living in an intensified pace of work and life, or rapidification. Rather, Thoreau, he goes to the woods. He seeks to cast off what he calls the mud and slush of opinion and prejudice and tradition and delusion and appearance, that alluvion which covers the globe. And rather, he seeks to live deliberately, front only the essential facts of life, and genuinely experience the world around him. And so today, here's a quote from Pope Francis in his encyclical Fratelli Tutti. And he writes, "Everything then depends on our ability to see the need for a change of heart, attitudes, and lifestyles. Otherwise, political propaganda, the media, and sources of public opinion will continue to promote an individualist and uncritical culture subservient to unregulated economic interests and institutions at the service of those who already enjoy too much power. So a few themes we see here. The uncritical culture that Pope Francis describes, that's an aspect of Thoreau's notion of the common mode of living, right? It's uncritically accepted conventions. We see the media is promoting, according to Ed Herman and Noam Chomsky's propaganda model, media ownership creates bias that actually promotes materialistic consumerist lifestyles through both the media being monopolized, where 90% of US media is controlled by 6 major corporations, and also these major corporations being reliant upon advertisers for revenue. So Chomsky and Herman's propaganda model describes how that ends up making these organizations privy to uphold the status quo and ending up, therefore, promoting materialism and consumerist lifestyles and the status quo of our society, which is a capitalist society. And so that ends up profiting societal institutions which enjoy a lot of power, corporations, wealthy individuals. And the result of these lifestyles, which are in part due to media, is this number you see on the screen, 6,558. And that's the number of million metric tons the United States, million metric tons of carbon the United States released into the atmosphere in 2019. And these directly are related to our lifestyles, where we have transportation, we have airplanes, ships for moving our goods, individual cars, we have electricity, powering our technological devices, our homes, we have industry from our consumer goods, agriculture, largely from eating meat. So these lifestyle choices, which are the common mode of living in the United States today, are releasing massive amounts of greenhouse gases, actually about 20 tons of carbon per capita, which is the #1 per capita emission rate in the world. And the issue with releasing these greenhouse gases is that the Earth absorbs solar radiation and then re-emits it in the infrared wavelength. And so these greenhouse gases, they have vibrational frequencies of their molecules, which correspond to that infrared frequency of radiation. And so this, along with the changing dipole moment or charge distribution of these greenhouse gases, allows them to absorb the infrared radiation and re-emit it as heat into the atmosphere, which in turn causes global warming and its effects. And the Keeling curve you can see in this upper right corner shows that carbon dioxide levels in the atmosphere directly correlate to industrial activity. So we do know that our greenhouse gas emissions and industrial behaviors are driving climate change. The impacts of this, as some of the other presenters already noted, are going to have warming by 2100, according to the Intergovernmental Panel on Climate Change, an increase in the frequency and intensity of extreme weather patterns, sea level rise, which is largely due to thermal expansion, where water as you decrease its density, when it warms, it decreases density, it occupies a larger volume. And so this will inundate our coastal areas, threatening economies, infrastructure, and the livelihoods of the 40% of the world's population, which live within 100 kilometers of the coast. Another effect, ocean acidification, threatens marine ecosystems and phytoplankton, which produce about half of the Earth's oxygen. So every other breath you take, that oxygen likely came from phytoplankton. So these are going to be threatened by ocean acidification. And it's important to note that these effects are going to disproportionately affect poor, low-lying countries. And these countries are not the ones majorly responsible for climate change. Some of them emit less than 1 ton of carbon per capita every year. And the United States is emitting 20 tons per capita. Yet these are the people who are going to suffer most. So there's an inequity there. And so now that we've talked about the climate change impacts of our lifestyles, the final chapter of my work focuses on literature showing reconnecting with nature can profoundly impact our relationship to the environment. And so Henry David Thoreau writes, "It is glorious to behold this ribbon of water sparkling in the sun, the bare face of the pond full of glee and youth, as if it spoke the joy of the fishes within it and of the sand on its shore." So his reverence for nature in this quote is obvious. And he later observes the woods and writes, "Am I not partly vegetable mold and leaves myself?" So he sees a sense of interconnectedness with nature, and he has a reverence for it after spending so much time in proximity with it. And this similar sense is embodied in the writing of Liz Clark, who you can see on the screen. And she's a writer, an environmental activist, and she sailed across the Pacific largely alone. And so she writes, "Looking out at all the sacredness surrounding me, I fear that if we never have these sorts of close encounters with open spaces and wild places, if our only contact with wilderness and animals is through a television and pets, we risk not caring whether they exist at all." So this sense of interconnectedness and reverence is also evident in her writings after spending so much time on the sea. And Pope Francis notes that this is an essential aspect to solving the climate crisis in his encyclical Laudato Si. So he writes, "If we approach nature and the environment without openness to awe and wonder, if we no longer speak the language of fraternity and beauty in our relationship with the world, our attitude will be that of masters, consumers, ruthless exploiters, unable to set limits on their immediate needs." And so in this quote, you can see if reconnecting with nature instills in us a sense of awe and wonder and fraternity with the environment, that can change our relationship to the environment. And so to wrap up today, we began with a literary discussion of Henry David Thoreau and his notion of the common mode of living and how that characterizes consumerist lifestyles in the United States today. Then we discussed briefly the role of media in creating these lifestyles, and then the result of these lifestyles on the environment, creating anthropogenic climate change with all of its impacts. And finally, we discussed literature shows reconnecting with nature may be an avenue to alter our harmful, exploitative relationship to the environment. Thank you for listening, and I hope you enjoyed.
Thank you. Great job. I did have a couple of questions for you right now. So since your project is a little bit different than the ones from environmental ocean sciences, can you tell us a little bit more about your research process, what you did to put together this presentation?
Yes. So my background, right, in interdisciplinary humanities, largely made this I came at this from a literary perspective. So it's Pope Francis' mentality that science is important and we need technological solutions to the climate crisis, but really the root of the ecological climate crisis we're facing is the human relationship to the environment is broken. And so that is something that needs to be addressed from a humanities perspective. And so that's what I did here with using mostly literary analysis, reading Henry David Thoreau and reading Liz Clark, and also drawing from more political thinkers like Noam Chomsky and Ed Herman to look at different factors affecting our lifestyles today and how these then using science, right, looking at how these drive climate change.
And how did you put your reading list together? Like, how do you even, I mean, there are so many sources out there. How do you decide on which ones to focus on?
Yeah, it was, so that, one thing I learned in this research process was I had a lot of breadth. This project had a lot of breadth. And so I did draw from a variety of sources. Some I'd become familiarized with through classes like Pope Francis encyclical Laudato Si, and I really followed what interested me and what kind of pieces I saw fitting together. and those connections, you know, seeing Pope Francis talk about the role of corporations in you know, prioritizing profit over the environment, and seeing connections all the way back to the 1800s with Henry David Thoreau and his ideas, and then Liz Clark's ideas, and so drawing connections was one thing I really found inspiring across these different works. And yeah, I just kind of pursued what I found interesting and thought would help inform the project.
Oh, let's see. We did have a comment about great example of the value of interdisciplinary approaches to understanding and solving climate change. And yes, that's why we wanted to highlight your presentation today. My last question to you is, how did your sailing trip impact you? And then how would you encourage all of us to reconnect with nature?
Yeah, thank you. So it's important to note that in the United States, there was a 2020 survey by the American Center for Progress, I believe, and they talk about the inequity of access to nature. And so that's actually an important issue to note on this topic. And so we need to work towards equitable access to nature for people regardless of race or socioeconomic background. And we see communities of color and lower income brackets living in nature deprived areas, having less access. But the sailing journey for me, you know, it was interesting. I arrived in Santa Barbara and I called my parents and said, hey, I'm in safe. And they said, whoa, Sam, something is different about, like, something has changed. Like, what's going on? And I felt a sense of peace inside from spending so much time away from technology, away from, you know, phone notifications, emails, news, media, whatever. I've been for 17 days holding the wheel of a boat for, you know, 6 hours a day or something, and just looking out at the ocean. And so that sense of peace is something really important to note. And part of the idea in the introduction to Walden that Bill McKibben gives is, he calls it the great hum of bombarding messages from society. And so these make it difficult for us to discern our own genuine thoughts. How do I know what I want? How much is enough, you know, for me genuinely to come up with that answer? And that's difficult in a society where you have CNN here, Fox News here, Instagram here, Facebook, your friends, the common mode of living is all around you. We exist in it. And so how do you genuinely discern things? So I think that's a big issue for our generation, is kind of clear discernment in this age of information.
Well, great. Thank you again so much. Great job. Before I move it back to Kara, I just wanted to mention that all of these presentations, all of these students participated in our virtual Creative Collaborations Undergraduate Research Conference. Creative Collaborations is our undergraduate research conference that we hold every spring, but for the past 2 years, we've had to hold it remotely. And they all participated, and the presentations are still available. And so I put the link to the conference in the chat box if you're interested in it. If you don't have a USD email address, you can just email us at ugresearch@sandiego.edu. To be added so that you can view the presentations. And we are also partnering with Digital USD through the Copley Library to post presentations from Creative Collaborations even before we were remote. And so a lot of those are already online. I'll include a link in the chat box for the presentations from 2020, which were also virtual. And those were a lot of video recordings of poster presentations and slide presentations that we saw today. So thank you again for participating and attending today, and then I'll send it back to Kara.
Thank you so much, Elisa, and thank you so much to Parker, to Gabby, and to Sam for your presentations today. It was such a joy to hear from each of you and to reap the rewards of being able to hear about your work and all of your hard research. So Thank you to those of you who participated as well in listening in. I do have this ending slide here for those of you who joined us early on. You probably saw a sneak peek at this. I had mentioned in my intro that we've hosted roughly 300 virtual programs since last March, and we are not letting up off the gas, as you can tell by what is in the pipeline in the next month. So there is no shortage of opportunities to stay connected with USD, to hear from fellow alumni, professionals. So you can see here that the maternal mental health, improving your sleep, the benefits of meditation, these are all sessions that are actually being led by alumni professionals. And we have a few alumni spotlights, a few alumni business highlights with the stir crazy cocktails, and so on and so forth. So great opportunities to stay connected with your alma mater and with the University of San Diego. And with that, I will go ahead and wrap us up. Thank you again to our presenters. Thank you to my colleague, Elisa. It's been a pleasure to spend this time with you. Take good care, everyone.